Here we're graphing this piecewise defined function, and we have the restrictions here: 2x minus 1 for x values less than 2, 4 for x equal to 2, and negative x plus 6 for x greater than 2. So we have three different scenarios that we want to be aware of. Now the first one I want to talk about though is 4 for x equal to 2. So first of all, what does 4 mean? What is the graph of just 4? 4 is just a horizontal line along 4. Now we have this restriction though, x equal to 2. So what that means is that we only want the graph of 4 at x equal to 2. So at x equal to 2 right here, we want just 4. So it's just going to be a point at the y value of 4 for x equal to 2. That's it. There's no line or anything. It's just that point. Now what we're going to do is we're going to create 2x minus 1 around that on the left side of that. And then for x greater than 2, we're going to want negative x plus 6 on the right side of that. And there's a couple different ways you could do this. So 2x minus 1, you could use slope intercept if you're good with that. Like if you're able to see like, okay, this is going to be negative 1 right here, and then you travel up, which is probably fine for x less than 2 because we could start at that y-intercept. So for the left side of this value of 2, I'm going to use just slope intercept and use the slope and the y-intercept as my indicator of what this graph is going to look like. So my y-intercept is negative 1. And then my slope is 2, so my slope is 2 over 1, meaning I'm going to go up 2 to the right 1. So up 2, 1, 2 to the right 1, 1, 2, right 1, up 2, 1, 2 to the right 1. So here's where you have to be careful though, because if we go up 2, 1, 2 to the right 1, we're going to fall on the restricted point because we don't want when x equal to 2. So what we want to do then is I'm going to grab just a couple going down. So down 2, 1, 2 to the left 1. Just do the opposite, down 2, 1, 2 to the left 1. And then here is what this line would look like. Now, as we get to that restricted point, that x less than 2, because we don't want it at x equal to 2. So I don't want a point, 1, 2 over 1. I don't want to put a point here. So I'm going to go here, and then I'm going to put like just a open circle there, just to kind of get an idea of what that's going to look like. So it's just going to go up to that point, but not at x equal to 2 because it's not less than or equal to 2, it's just x is less than 2. So it has all the values of x less than 2. All right, now let's do the right side of 2. So that's going to be the graph negative x plus 6. And this is where it might be a little bit easier to just take some values because we're going to have to just visualize what this would be. So y-intercept of positive 6, our slope is negative 1 over 1. So that means we're going to go down 1 to the right 1. So y-intercept of 6, down 1 to the right 1, down 1 to the right 1. And you'd probably be okay doing this, but I'm going to just take a couple of values. So let's do f of 3 and f of 4, plug it into here just so we get an idea of what that's going to look like. F of 3 is going to be negative 3 plus 6, which is going to be positive 3. F of 4 is negative 4 plus 6, which is positive 2. So for 3, 3, we're here. 4, 2, we're here. So it's going to look something like this. So it's kind of funny that negative x plus 6 and the constant of 4, they're kind of meaning at the same point. Because if we plug in 4, f of 4, it would be negative 4 plus 6, which is 2. So we're kind of just coming off of that constant point there. But either way, it's still that's what the graph would look like. So we have kind of a weird combination of 3 different graphs, but where 2 of them are meeting at the same point pretty much. So this red dot on my screen here represents this function. For x equal to 2, it's 4. And then this purple line is negative x plus 6. And you could have just used slope intercept if you're good at doing that, where you could just imagine where we would be. So you go down 1 over 1, down 1 over 1, and then you can start creating your line. But you could also grab some x values. And then this is what the 2x minus 1 would be for x less than 2. So I hope this helps with graphing piecewise defined functions.